I'll do the work in classes.
Yeah.
Like, not a big deal.
No.
I would be doing the same thing at home, but I'd be working on my projects on it.
Okay. So our next unit is radicals and absolute value. And we're going to start with radicals, which is something that we've done before. It's like roots and stuff like that. There it goes. The chapter is radicals and absolute value, and it seems like I'm shouting because I did this morning with grade 10 and we listened to it, and it seems like my voice is quiet, so I'm speaking louder.
Okay.
So, working with radicals, all this stuff which we have done before, but we'll review a little bit. But of course is the radical, and that right there is, any recollections on that? Yeah, so
whatever which one it is.
Yeah, I call this the notch.
The notch.
But that's the index. And where's the notch? It's in the. And what's underneath the radical is called the radicand. All right. As always, we are simplifying. And let's start with hopefully a super easy one. The square root of 9 is. And once we take the square root of something, the radical's used up, it's gone. So I know last year some people would keep it. That's the last year. And then last year we talked about how to handle something like the square root of 27. Because we want exact values. So we just rewrite it the square root of 9 times 3. And I think last we wrote 2 radicals, but I'm not doing that anymore. Yeah, because the square root of 9 is 3, comes out underneath the radical, but the root 3 stays root 3 because it is root 3. Not McKenna on this one. Square root of 48. No pressure. You got this, buddy. Oh, McKenna. 12. Okay. So I'm going to put the 4 in front. Square root of 4. So this is perfect because I'm going to ask you, are we done? So that means we could have found a bigger perfect square. So what can we do with the 12? 4, 3. Yep. Yep. This step is not necessary, but I'm just kind of showing how everything lays out. Which means that and we picked 16 and 3 and got the biggest perfect square off the hop. We got it done in one step. So the whole thing is what I'm saying here. Sometimes we don't find the biggest perfect square. We have to keep going. So be careful with that. One more. 4 root 75. That's a lot you guys got.
Stop in the name of the law. I don't know.
Okay, 2 numbers. 3, yeah. So this kind of is a little bit of what Barrett did in the last one. But we take the square root of 25, we're going to get 5. Well, what do we do with that 4 and that 5? Yeah. Yep. Again, I don't know that I need to be doing this step, but I just am. But you do not. You can go right to here. You get it? Got it? Good. Questions through here. This, I think we've done before. Yeah. Oh, wait. Variables. We're on E. If I square root of x squared, that's pretty straightforward. We've been doing that forever. That's just yes. We're going to answer an answer that he's confidently and loudly. If we are taking the square root of something like y to the 6th, what's our rule again when we have exponents bigger than 2 or take the square root? Or have we done that before? I don't remember these rules. That's what I show you stuff. Brett's face says no. Okay, so let's just make a little note that we divide exponents by 2. So when we're taking the square root of something, the chances are your exponent is going to be an even number. If it's a cube root, you probably have to divide the exponent by Skylar. I'm taking the cube root of something. What do you think we'd divide the exponent by? Okay, good. So for this one, our answer would be say it loud, say it proud. Oh, geez. Kind of jumping the gun there, Mary Skyler, but you have this one. If I'm taking the cube root of y to the 12th power, we'd get what? Exactly, because we divide, let's say in the notch, by our exponent. And sure enough, if you just take a minute to check it if you're so inclined, oh yeah, we have the exponents, 4 plus 4 plus 4 is 12. Exactly. That's good. It's good. Okay. I want to do the cube root of x to the 7th. Ideas here are very much the same thing as when we take the square root of 50. That we can't take the square root of 50, but we can make it into a product of two things that one of them we could square root and one we can't. Same thing I do with this. Bring it apart into something that we can cube root, and then get what's left over. What's the biggest exponent divisible by what number is in the index? What's the biggest number that's underneath the radical that's divisible by 3? So then we can break it apart. So that would be x to the 6 times x. I'm just going to write one just to show how it adds up to 7. And then can we take the cube root of x to the 6? Just again, divide them evenly. So what would it become? Again, we used it up, but still, and all the little details, the number in the index, it's just, it all kind of needs to be there. It's the devil's in the details kind of thing. Questions on that one? So it doesn't really matter what I have in the index or in the radical, it all kind of follows the same thing here. So, h, if I'm taking the 5th root of x to the 13, y to the 22nd, we could rewrite that as answer of
X cubed, so like the X to the 3, and then it'd be Y 4 to be like X, X3, Y2.
Oops, second x is not correct. Fix that. So still in the fifth root, x cubed, y squared underneath the radical. I'll fix that 3 eventually. There we go. That's exactly it. Better break them apart. Take the fifth root. Questions in there? One more that McKenna's not going to help with. Okay. So h, oh, I got 2 h's, oh well, cube root of 40 m to the 7 p to the 5th power. So now there's even numbers involved. I don't know, Chloe, I haven't talked to you too much today. How can we break apart this? Here, I'll start with the radical. Yeah. What number of numbers multiply to get 41 of them we can cube root? Square root, but not cube root. To the numbers that give me 40. So you said McKenna, give a hand on that. So let's multiply and get this one. Yeah, that's right. 8 and 5. And what can we do with the m's and the p's? Back to you, Chloe. Yep. So m to the what and p to the what? There you go. Yeah. And how about the p's? P's. Yep. Absolutely. And that simplifies too. I don't know. Help it out anymore. Brianna, can you finish that for us? You don't know what's the cube root of 8? What number? What's the cube root of 8? So not cube root of m to the 6th, Brad, I guess. Divide exponent by what's in the index. So we would write.
Business. It's just dividing it by 3. So you're taking the exponent and then we're dividing it by 3.
But 8 divided by 3.
What number times itself 3 times gives you 8?
Because it's 2 times 2 is 4, 4 times 2 is 6. So how is 8 and 5?
40 times 5. 8 times 5 is 40. Cube root of 8 is cube root of m to the 6th. It's like McKenna said.
How is 3 the cube root? How is 8 and 5 the cube root of 40?
Because 8 times 5 equals 40, and then.
But that had to be 3 times itself.
No, so it's 8 times 5 is 40, and 8, it's like, you know, when you're doing the square roots, and you have to find one number that's square rootable. you're finding,
Oh, so you
finding
don't
one
actually
number.
get rid of the three?
No, it's just 8 is cubable, like you, because it's 2 times 2 times 2.
As long as one of them is cubable?
Yeah, just you need one number that's cubable or squareable or so on and so forth.
Yep.
Right?
Yeah.
Not just,
And when we're breaking apart the terms with exponents on them, we make them divisible by the number in the index. So, like Chloe said, there we went 6 and 1, and then Barrett said 3 and 2, because 6 divided by 3 is, of course,
2.
So then m squared. I'm just putting a line through to make sure I don't miss anything, and then the cube root of p cubed would be, yeah. That's used up too, but I still have my cube root, and everything did not get used up. So what can't we take the cube root of? And squared, yes. It might be something where you can make a list.
of the cubable.
Yeah, because like what? I like up to 7 because 7 is hard to recognize. The cube root of what gives us 3? The cube root of what gives us 4? Cube root of what gives us 5?
How do you like to figure this out? Are you just like on brain power?
Yeah. No, I'm just typing it really fast.
Cube root of what gives us 6? And this one that you would never think of, but the cube root of what gives us 7? Yeah, 343, really? Like, that's a weird number, but sure enough,
It works.
that's the cube root of 7.
So it's pretty much 7 times 7 times 7.
Exactly. That's exactly what it is. Exactly. And some people just burn it in their brain. Some people write it down a few times so they get used to seeing it. I can see you're happy about it, Brandon.
Where
Questions?
is this on YouTube?
You're living it right now. Or you can just search my name.
If I like want to like look for it for exam or something.
Just search.
Mr. Bob.
Search radicals and search also whatchamacallit, Khan Academy. That's very good. Spelled like that. But we're not done yet.
Oh, yay. More.
Oh yes.
Yay. I was like, this is going to be so easy.
It's not bad, but it's not, I don't know. I don't know where we are for examples. I think it's K.
Yeah.
And we did this last year, where we have it simplified, but we want to put it back into a radical. But I'm pretty sure I talked about use the index so you know how many times you put the number in front underneath the radical. Because here since it's not written, it must be written in our roots, which of course is 2, so then how many 6s do I need to write underneath the radical? So we'll multiply.
Oh, and
Oh, good. So 6 times 6 times 3. Skylar, it's that great when you know the number, but you're not saying it.
100.
Okay. Good. And the only difference, I guess, this year would be is that, I don't know, maybe we even had this last year with different numbers in the index. Probably did. But really, the index just tells us how many times to write the number in front underneath the radical. Brandon, you said you remembered what this would
no, I
be.
don't anymore for that.
To do 5 times 5 times 5 times 2.
And it says there's 3.
That would be
stuff. I really don't need it. What's that? Let's do one of the variables, because this is too easy with numbers. Okay.
Great.
X cubed root x. And basically the point of this example, it doesn't matter what's in front of the radical. As long as you understand what square root and cube root and to the fourth root or whatever the number root is, just use that to tell you how much shit whatever you got. Skylar, look deep in thought. What would I be writing here? You could, for sure. Or just go x cubed times x which is exactly what you said is x6 for a total of. Yep. That's exactly right. Questions to write here. Almost done. Six examples left. I tried giving this assignment without this as an example, but it never works out, so I'll do this too. Write as a square root and as a cube root. Because I assume my assigned questions like this go on what do I do? Every year so I stop doing that again without doing this first. So if I have 10 and I ask you to write that as a square, 2, and I ask you to write that as a square root, what would that look like? Or what the square root of what gives us 2? And then I'll stop. In the same way, the cube root of what gives us 2? Yeah. Exactly. Now it's a little bit harder. 6 m. The square root of what will give me 6m? Yep. And the cube root of what is going to give me 6m, or give us 6m? Yep. You got it. You got it. Last two. Same thing for 2c squared. The square root of what gives us 2c squared? The cube root of what gives us 2c squared? Yep. Since you got the last three, Barrett, let's now get the last one. You got it. You got it. Questions? Okay, in your textbook, on page 278, 1 to 4 and 5A